All right, so I'm going to be honest, this is not my favorite thing to share with students when we're working with normal curves, because sometimes people decide this is the way and then they don't show me all the work that I'm actually looking for. So this is a backup to check if your work's all right, to see if you've made a mistake. This is not the work itself. Here is the deal. There is a section of your calculator that has all this normal curve stuff that we're using right now stored in it. And you're going to be finding it in a slightly strange place. It's called distributions. It's right here below the arrows. So you want to go second vars to get there. And when you get there, you're going to find three things in the normal section. Now, normal PDF, not very helpful. It'll tell you at a particular value how much area there is. The answer is pretty much always 0. Normal CDF is going to be your shader. So it's a cumulative distribution function, and it's going to shade and tell you how much of your graph is shaded. And then I don't tend to use either of these. I don't like it when students use these because they tend not to do all the graphing work that I'm asking for. The one I tend to use is in this one. This is the reverse lookup. So if I'm trying to find the 90th percentile and I haven't quite found it and I'm not sure which one's closer, this might be the way to go. So these are the three things I want to show you. In fact, I'm going to start with this one. So I'm going to do this backwards question here, the 30th percentile. So I'm going to have to start with the graph. I haven't sketched it yet. So we have Clayton Kershaw of the LA Dodgers throwing his fastball with a mean velocity of 94 miles an hour and a standard deviation of 2. And they are telling us that can be modeled by normal distribution. So I'm checking shape. I'm going to make sure I tell myself this is a normal curve with a mean of 94 and standard deviation of 2. And I'm doing that because I want to check if my numbers seem reasonable when I'm done. I'm looking for 30th percentile. So heads up, inflection point. Below the inflection point, I'll find 16%. So I would like to take a chunk of the bottom of the graph that's a little bit more than that. And then I'm going to say, hey, this is 30th percentile. So I'm turning that into 0.3000. It's a proportion. And I need that either to look it up on the chart myself or to ask the calculator, right? So I could be looking for 0.3000 here. And this is a tough one. They're both kind of far apart. This one's closer, so I would go with negative 0.52. And the calculator can help me with this. So I'm going to try inverse normal. And it's saying, what area would you like? I would like 0.3000. And then this is the mean estimation of the graph I'm working with. So this is going to be this guy. Oh my God, why did you do that? That's not what I was looking for. Hey, I must have had my calculator do weird things before I got to that screen. So inverse normal, I would like this area shaded to the left. When it does paste, it just types it into your normal typing screen. So if you don't have the menu, you need to be typing the stuff in. You don't actually have to do the 0, 1, just the 0.3333, the 0.30. And it'll tell me my z-score, negative 0.5244. So that's why it was kind of tough to choose. It was pretty close. So it's helping me choose negative 0.52. This is also why sometimes you might get more detailed z-scores in some situations. So those are retrievable from the calculator. So this has told me that the z-score of this 30th percentile is a negative 0.52. Now, there's a way to get more of that. If I go to distribution again, if I go to inverse normal, I can ask it to find the area 30% for a graph that has a mean of 94 and a standard deviation of 2. And in that case, it'll tell me the actual speed of the fastball. So it's saying, hey, that's a 92.95. That seems like a reasonable number given where I'm at, right? But heads up, guys, it doesn't give you the z-score if you do this guy. So the z-score is pretty much always necessary. So be very careful with the work you leave behind. So what I would do for this problem is I've found the z-score, the chance of having a z-score of less than negative 0.5244 is 0.300. I would write that down so it doesn't disappear on me. And then I would say, hey, how you get your fastball speed is really up to you. So you could just write it down or maybe write the work. But this would be, that's the work I'm doing next to find that number that the calculator said, the 92.95. So that's going to be 2 times negative 0.52. plus 94. And that gives me 92. Now, if I do it by hand, it's not going to be nearly as precise as it was on here, but we would say a 93 mile an hour fastball is the 30th percentile. And just a reminder, percentile is this person's speed, or this particular fastball speed is higher than 30% of other throws.